Hey guys, this week it's a bit of a special home built by Jeff because I've actually travelled all the way out to LA and I'm here with Neil at Performance Development and we're actually going through and doing all the machining for my engine. Alright guys, so if you follow me on Facebook, you might have seen some of the photos I put up on Facebook and Instagram of what these heads were like before. And what Neil has done before I got here is he's gone through and fixed 5 of them. What he's gone through and done is he's re-drilled and put inserts into them, machined up, made up new custom inserts, and then re-drilled the inserts and then re-machined it all flat. As you can see here, here's one that hasn't been drilled out again yet. It's just had the inserts and the machining done. So even if they are butchered, sometimes they can actually be repaired. What we're going to go through now is, with Neil's assistance, because I want to do everything on this car myself, I'm actually going to have a go at doing every part of the machining on this engine myself as well. Obviously with Neil's expert guidance. So let's get on to this first head. This head here is one of the ones that I'm going to have a go at repairing, and this hole is one of the ones that they mangled previously. So what we're going to do first of all is we're going to drill it out, and we're not overly concerned about where the center is because we're going to line that up and do that out later. We just need to drill it out first, get it to a much larger size, and then we're going to go through and we're going to stick in this custom aluminium insert. This will be threaded into the head, then machined off nice and cleanly, and then re-drilled with the perfect center that we actually want in the head. So, all right, let's start drilling this out. All right, so now we've drilled this out, we need to tap it, and to tap it and keep it square, we're going to use the tap and the tip of the punch into the tap to keep it nice and square and straight. All right, and that's all threaded and tapped. The next step is to clean it all out, and then we can put our insert in. So now I've just got a bit of Loctite on the insert, and now we just thread it back into this head. And there we go. Insert in. Next step is to machine it off. Basically, we've centered now the whole machine using this little dial indicator from the center here, and now we have the center point. We know to be able to drill out these holes, we know they're 80mm spacings, so we move up 40 and across 40, and we can drill that one down 80. Should be quite straightforward, so let's start drilling out some heads. So that is the mangled mess of the head tidied up. I think it looked much, much better. We've got this last head set up on the lathe, and what I'm going to do is I'm going to be machining out this plug that we put in there back to the levels. Alright, the next thing we're going to tackle that Neil was just telling me about on the heads, which is something that he specifically does. In the base of where the head studs go, there's actually damage from the washers. If the seat is not nice and flat and square, and it will actually taper the seat and put pressure on the seat. So what he does is he goes through and seal in these step washers, and this actually creates a nice solid firm seat for the washers. You get good solid head tension so it doesn't loosen off over time or anything like that. So let's start putting them in. Alright, I thought I'd just go over a bit more here what I've been doing with these heads. What I've got to go through is I'm going into each of these holes where the heads are bolted down. What I'm creating is this. So the first bit drills this step flat in the hole, and then the next is we drill down this piece here so that the insert, this step washer, so that washer can sit in like that. So I'm going in I'm drilling the step down, then honing it just to make it nice and clean, and then I'm cutting it the chamfered edge. It's just to take the corners off, so when I try and press this piece in, it doesn't drag things down into the hole, and has a nice, neat, clean, flat, level fit. And this is an extra step. It's just an extra precaution. It's a little bit more work, but it will make sure that it's all perfect when it's done. So I'm 3 heads down. I've got 3 more to do. So the next job I'm going to tackle is I'm going to go through and I'm going to clean up these valves, and it's just a simple matter of putting them on the lathe, hitting them with a bit of Scotch-Brite, and give them a bit of a clean. So let's start working through all these valves. Next quick job is to go through and look at all these valves and measure the stems to make sure they're still all within spec. Next step is we put all the valves into this contraption here, which locks the stem of the valve in down the base here, and then this dial indicator just sits on the edge of the valve, and just turn the valve around, see if it moves to check whether the stems are actually bent or not. Next step, let's do all of these. Okay, the next thing we're going to go through and do is we're going to dress the valve. So, which is basically, we're just going to make sure that the edge that seals on the head is nice and flat and neat and even. And that's what this machine is for. Alright, when I was measuring out the valves, there were a couple of the exhaust valves that were looked like they were a bit bent. One looked like it was quite badly bent, and you can actually see here where it's machined one side and not the other. So it's obviously quite a bent valve. So this valve is toast. This valve, and same thing with this valve. So I need 2 new valves. Great. Alright, so Neil's got me onto the next task, which is removing the valve guides. And basically they're a press fit seal, so what we do is we use this machine here, which it's actually a self-centering machine. We'll use this to basically drill out most of the valve guide first, and then we can knock it through because it's taken most of the strength out of it. So start drilling out some valve guides. Alright, so now we drilled out the valve guides to take a bit of the strength out of them. Now they've been heating up in the oven for a while, and they are super hot. So we're going to take them out and take them over to the press and press out the valve guides. Delicious pies. So now we bring them over here, we sit them up on the shop press, and we press them out. In some ways this system is a little bit of overkill, but it ensures that these 40-year-old heads don't get broken or damaged in the process. So some people just push them straight out, but they can potentially cause damage. It's all good, just a pin falling through. So take the head off, put it on. We've got another boss that we put underneath. This time for the inlet valve, and we spin around and do the same thing again. And there we go, the valve guides are now punched out completely. Alright, my next job is to go through and start repairing my mangled case. Now, Neil has spent a bit of time here lining this up and getting everything square and straight. The main issue with these old 2.7 litre engines is that they were designed to get hot to burn off cleaner for emissions, and when they got hot, they ended up pulling out the head studs straight out of the case. And a common fix is actually putting in these, which is a case saver. It's got a very thick, coarse thread, the finer thread inside, and this bites into the magnesium much better, and they don't pull out. You can't use helicoils or other things like that. Case in point, somebody's trying to use helicoils in here and they're useless and they're pulled. We'll start with the worst hole and repair that. Now, I don't know how well you can see here, but this bit is perfectly centered to where this hole should be. Look how far off center they have drilled this hole. They've had one go at it and drilled it in the wrong spot and thought, oh yeah, I'll just jump over and move over, and they're still way off where the center should be. So that's the issue we have now. Is if we try and drill this hole from this center big enough to repair damage, we will break through this side here. So what we have to do is we have to center our repair off of the bodgy hole they've done. This is the worst hole we have in this case. Basically what we've got is where this large hole is the hole we're drilling out to put our case saver in. That little cross is actually the center of where the stud should be placed. So they've drilled it so far over, we can't go anymore because otherwise we'll start cutting into the edge of the cylinder bore. So the issue we have is this dotted line on the inside is actually the line of where the threads are. They intersect, which means that we're going to have to actually tap through where the threads are, which is not going to be as strong. What we're going to do first though is to test our method and make sure that we're not just going to waste a case. Do a test piece of exactly the same method as this. We can use the exact same measurements so we get the same offsets, and we're going to do that into another piece of aluminium, put the insert in, try and then put a bolt in and torque it up way past specs, heat it up, and basically simulate a potential stress of what the insert will face, and see if it pulls. Alright, so I'll take you through what we've done here. So what we've actually done is we've drilled our hole, same as the hole we have in the case. We've put our steel threaded insert in there. Now we have center punched on the exact same distance off set where the hole is supposed to be, same as on the case. The issue that we had there was this bolt was starting to stretch. The threads are still fine, so we've found some better quality bolts. It's already coming up much better, telling us that obviously the bolt's not stretching. There we go, torqued up at double the factory spec. We're happy enough, we're confident that our test was well and truly strong enough. We put well over 70 pounds into it. We actually we went as hard as we could physically move it, and the thread didn't move. And that was also the bolt only had half the amount of thread that the head studs will have. Now, guaranteed that's fresh aluminium compared to 40-year-old magnesium. Confident that our fix works, so there's nothing else to do but to repair this case. Okay, so we've drilled and tapped our hole, and we've made up an insert. So this is actually the exact same size thread, the same diameter, same size thread as case savers. This one is just one we've made up ourselves, with a bit of a tapered end on it due to the shape of the tap, but it's actually longer than a standard case saver. With a hacksaw, we've just scored the end of it so we can turn it with a screwdriver. And so now we're going to put some Loctite on it and chuck it straight into the hole on the case. We've set this in, Loctite's on there, so now we're just going to wait for it to all set up, and then we can come back in and re-tap the hole in the right spot, and we should be done. Okay, and here it is, all finished, all drilled and tapped. The stud is in place, and we actually got the machine back and set it right on top of the stud, and it is perfectly centered in the right spot. There's really no other way to repair this case, and it does have steel all the way around. We're confident it's going to be well and truly strong enough. That's it, so that's repaired. So now we can move through and do all of the other holes. And okay, I'll run through now a bit more about where we're going to go and what still needs to happen with this case. So what we're going to finish off doing is all the head stud repairs, and then the inside just need get lapped. They get bolted together, and then everything is measured and line bored. Running a bore through to make sure the crank mount, everything is all the right size. When these are bolted together, these are going to be dowed, and typical way that a mag case would be dowed is where they drill holes here either side of the through bolts, and they put small pins, dowels, in these areas. What we're going to do is these through bolt holes are actually going to have hollow dowels in them. We're going to drill them out, place a hollow dowel that goes half in there, half in the other, and the point of the dowels is to give a solid mount so that right either side of the crank, so that there is no room for movement. Once it's all bolted up, it should not move. Another thing we're going to do is the oil bypass mod, which is when the oil pressure release valve builds up too much pressure and releases the oil. Originally, it releases it back into the bottom of the case, so the scavenge pump has more oil then to work harder to push out. And basically what it does is drilling some holes through the base of the case here, and it releases it through to the intake side of the pump, and it comes back through and back into the system that way. It's a common modification for all these early engines. All right, and that's the case. All right, so the next thing we're going to talk about is this crank. So it's already been magged, which is a process where it goes through and they test to see if there's any cracks or anything, and it's not cracked. Then he's checked to see if it's straight or if it's bent at all, and there is actually a slight bend in it, but it's apparently very common, and he can straighten it and get it all sorted out. The next thing we're going to have a look at is that there is some scoring on some of these journals, and to repair them, it's too much to be just polished out. They're going to have to be remachined and get bearings to match. The oil travels through the center of the crank and comes out some of these little holes into the underside of the bearings to keep the bearings lubricated. And if there's any scoring on them, then the oil doesn't travel where it's supposed to, and they can wear out. This is my standard rod. So you can see there, it runs a 22mm pin, and it's quite a heavy, chunky piece of gear. I mean, it was developed 40 years ago. What we're going to do is we're going to take a little bit of more modern thinking. Neil's going to go through and do a few bits and pieces to make these a much better design than what they currently are. So what I have here, this is a rod for a Mclaren, which is standard 600 horsepower, and it has a tapered top. If you compare it to my rod, Neil's going to taper the top of these rods, so we're going to get a bit of weight out of it. There is plenty of strength there, and also instead of running the 22mm, we're going to go down to an 18mm pin. So again, this 18mm pin is actually one from this Mclaren, which is built for 1200 horsepower. My engine's not going to be making anywhere even in the ballpark of that, and the standard Mclaren is 600 horsepower. If I make 250, I'll be happy. So you know, when we're talking much lower figures, because we're designing new pistons, getting a piston made is going to cost me the same whether it is a 40-year-old design with a really long skirt and really deep piston rings. This is actually from a 962, but I'm using it for example. We're going to take something. This Mclaren piston is much smaller, and it's got thinner rings, less friction. The other thing with the design of the piston, the small end is quite loose fit inside the pistons. What we're going to do is make it a tighter fit, like a modern design. This is a tight fit, and that's what we're going to be doing. So it'll be top guided. What we'll be doing with the cylinders is the cylinders are going to get bored out and recoated at 92mm up from the 90, and my custom piston is going to be available to whoever wants it. So and as I said, it's basically the same price as everything else. It'll require a small amount of machining on the standard rods, but ultimately it's lighter weight moving parts. We'll keep you abreast of it as it comes together, but when we get the pistons together, we'll show you a bit more. The next thing we're going to talk about is these cam decks. These hold the rockers, and the rockers sit in this little spot in here, rock on these pins. The trouble is when people remove them, they push them out and don't necessarily use the right stuff, and they score these holes. Once these are scored, even with the pins in, they leak. Currently we don't know how we're going to fix it, somebody here has tried silicon, and that's not really a proper fix. If anybody knows of the way to fix it, it'd be good to hear, but we'll come up with something, and it's got to be better than silicon. Okay, I thought I'd go through now and just show you a few of the bits and pieces that Neil's been working on here at Performance Developments. This here is a 997 GT3 42R. It's their version of the factory RSR race engine. It's their design crank. It's their design titanium rods, solid cam followers, 2-ring pistons, lots of details, but this is a pretty trick bit of kit. That they also do a 911 42S engine for a street version of this for the 997. Another thing that Neil's working on that I've found very interesting and quite disturbing is actually the 991 GT3s. And all the 991 GT3s, GT3 RS and 911R all have these same heads. What these have, instead of having rockers like mine, they have these very tiny little finger followers. Basically, these are wearing out because there's no oil getting to them. They're not getting enough oil, there's an issue, and quite a lot of GT3s have already gone back with the mysterious engine problem, and the engine's just been replaced. What Neil's developed, a brand new finger follower and repair for all the GT3 engines. He's developed a entirely new lot of finger followers and new oiling system so that they won't have these problems. Interestingly, the GT4 doesn't have finger followers, it has buckets like I showed you before for the Mclaren. This GT4 is actually developing as a 4.4 litre kit for the GT4, which is crazy. Alright guys, well that's it. That's my time here in LA done. If you're actually looking at doing any engine work, they don't just do top race engines, they do everything from 944 builds all the way through. Neil's background, he built engines for Formula 1 for 12 odd years and worked for Andial, which is basically Porsche racing in the US, building engines for them. Lots of knowledge, not just going off of what somebody on the internet told me. Can't recommend them enough. Wealth of knowledge there. So anyway, we'll see more once we get all the engine parts back, and when I get it all back to Australia, when I can start putting the engine back together, which will be a little while yet. We've still got things to juggle into place. As always, if you're enjoying the videos, please like and subscribe to my channel, Home Built by Jeff, and you can follow me on Facebook and Instagram at the same place. See you guys.